Let's have a look at this exercise now where we seek to turn this sum of a cosine and a sine function into a single sinusoid with an amplitude A and some phase phi. So the exercise has to find the amplitude and phase as a function of B1 and B2. I'll show you two methods to do this. The first is a brute force method using this trigonomic identity here. So what we're going to do is identify alpha as phi. So here's our cosine function here that we're looking to find. There's a phi, so we'll call this alpha, and we'll call our beta in this trigonomic identity root k&m times t, or omega t. So this here is our beta. So we take that and we multiply the whole thing through by a, so we get a cos omega t plus phi. According to this trig ID here, must be equal to a cos phi times cos omega t minus a sine phi sine omega t. Now, what we want to do is look at this side of the equation here and compare it to this side of this equation up here. And so if we do that, what we see is that a cos phi must be equal to B1 and a sine phi must be equal to B2, because here we have cos omega t and cos omega t, and here we have sine omega t and sine omega t. So here are two equations and our two unknowns, a and phi. We've got to solve this equation here for these unknowns in terms of B1 and B2. Let's start by taking these equations, squaring them, and adding them together. So we have B1 squared plus B2 squared must be equal to a squared cos squared phi plus sine squared phi. All of this here equals 1, so we end up with a squared is the sum of the squares B1 and B2. So here we have a in terms of B1 and B2. What about phi? Well, we can divide these equations, divide 2 by 1, so we get tan phi must be equal to B2 on B1. But note that you have to take care of the quadrant of phi, because this inverse tan function here does not return a unique angle. You have to make sure that the sines of cos and sine, the sines of these functions work out for you. So this is one method, a brute force method. The second method is a graphical method. So we consider the sine and cosine functions as phasors. So here is B1, which is the amplitude of the cosine function, and here is B2, the amplitude of the sine function, and these two are at right angles to each other. The angle here that they give is phi with some resultant vector a. And so what we do then is to say that using Pythagoras, a squared must be equal to B1 squared plus B2 squared, and the angle phi must be equal to the inverse tan of B2 on B1. Again, we have to take care that we get the direction of this angle correct, because the inverse tan function doesn't give us a unique value. So there we have two methods for solving this problem.